So dear students, so today we are going to discuss about our nuclear power plant. So in this nuclear power plant, we are going to learn about the main component of the nuclear power plant, that is about the nuclear reactor. So before going to the nuclear power plant and nuclear reactor, we will see the working principle of nuclear power plant. So the nuclear power plant works in the similar way of the thermal power plant. So the difference between is the fuel they use to heat the water. So the difference between the fuel they use to heat the water in the boiler. So in the steam power plant or thermal power plant, so we need to use coal for the generation of the steam. We need to use the combustion boiler for the source of the combustion is the coal. We need to we need to burn the coal. So in order to generate the steam. So whereas in the nuclear power plant, so we are using uranium. So here inside the nuclear power station, the energy is generated by nuclear fission in the core of the reactor. So in the nuclear reactor, nuclear fission. So the energy is released by nuclear fission in the core of the reactor. So one thing you need to understand the differences between the thermal power plant and the nuclear power plant. So 1 kg of uranium can produce as much energy as the burning of 4,500 tons of the high grade of variety of coal or 2 tons of 2,000 tons of the oil. So 1 kg of uranium that equal to 4,500 tons of high grade variety of the coal. So inside the nuclear power station, so here the energy is released by nuclear fission in the core of the reactor. So the 1 kg of the uranium that equal to 4,500 tons of the high grade of the coal. So that 1 kg of uranium that it will be liberated by 1 kg of uranium that equal to 4,500 tons of the high grade variety of the coal. So the main differences in the thermal power plant and uranium nuclear power plant. So the difference between is so here in the thermal power plant we are using the coal for burning of the fuel. Burning of the fuel is the coal. So in order to burning of the coal, we need to generate the heat from the burning of the coal. So that is in the thermal power plant. Whereas in the nuclear power plant, so here uranium inside the nuclear power station, energy released by nuclear fission in the core of the reactor. So when the nuclear reaction takes place in the nuclear reactor, then heat will be large amount of heat will be developed. So that heat we need to use the heat the water, or then the water will be converted as a steam. So now we'll see the now we'll see the nuclear reactions. So here we have two reactions, nuclear reactions taking place in the nuclear reactor: fission and fusion. So fission means splitting of heavy and stable. Fission means fission is a splitting of heavy unstable nucleus into the two lighter nucleus. Two lighter nucleus. Whereas in the fusion process, fusion is a process where two light nuclei combine together, releasing a vast amount of energy. So here, so mainly the fission process, the heavy and stable nucleus, that will be splitting into two lighter nucleus. When this nucleus neutron will be bombarding, polarizing, so then the unstable nuclei that will be unstable nucleus that will be splitting into two lighter nucleus. So then in that process, a large amount of heat will be generated. So large amount of heat will be generated to a fission process or either fission or fusion process. So we are explaining. Now we are going to move to the fission process. So this is about nuclear chain reaction. So nucleus. So this is about a proton and neutron in the uranium molecules, uranium-235 nucleus. So here we have a neutron, and then we have a protons. So these neutrons reside in a fusion. So neutrons within the fusion trigger the fission of the nuclei. Neutrons released in the fission, so trigger the physics of the other nuclei. So here these neutrons, the neutrons will be colliding or bombarding with each other. So it will be hitting on the another nucleus. So it will be bombarding. So here large amount of heat will be developed. So during this fission process, large amount of heat will be generated. So again, that nuclei will be splitting into another this nucleus. This neutron will be bombarding, hitting on this stable nuclei. So again, it will be converted to three more nucleus, three more neutrons. Again, these neutrons will be colliding, bombarding these other nucleus. So in this nucleus, we have proton and neutrons. So this neutron will be colliding. This neutron will be colliding these nucleus. Again, these nucleus will be splitting into these neutrons. So during this splitting process, so here large amount of heat will be generated. So this energy will be released. So this heat will be released. So this is about chain reaction. This is about a chain reaction. So neutrons released in the fission and trigger the fission on the other nuclei. So we have seen that unstable nuclei will be splitting into unstable nucleus will be splitting into so so the splitting of the heavy unstable nucleus into two lighter nucleus. So during this fission or fusion process, large amount of heat will be developed. Large amount of heat will be developed. So these neutron will be bombarding this nucleus. Again, this nucleus will be so these neutrons will be bombarding process during the bombarding process. Again, neutrons will be splitting. So these neutrons will be bombarding the other nucleus. So during this process, a large amount of heat will be generated. A large amount of heat will be generated. So fission process means fission is the splitting of heavy unstable nucleus into two lighter nuclei. So fission is the splitting of heavy unstable nucleus into two lighter nuclei. So during this nuclear chain reaction, large amount of heat will be generated. So here, this chain reaction will result in isotope in the form of uranium exists as an isotope. Isotope is in the form of uranium-235, which is unstable. So when the nucleus of an atom, when the nucleus of an atom of uranium is split, the neutrons release heat other atoms. The neutrons are released heat other atoms and split them into dark. So more energy is released each time. More energy, more heat energy is released each time of another atom splits. So this is called nuclear chain reaction. So this is called about nuclear chain reaction. So the unstable nucleus will be splitting into a nucleus, will be splitting into another neutron. So then again, that neutrons will be colliding and bombarding with the nucleus of the uranium. So during this process, large amount of heat will be generated. So this is about nuclear chain reaction or fission process. I hope you're understanding the concept of nuclear fission. So this is very important in the nuclear reactor. So now we'll move to the main component of the nuclear power plants. So this is about nucleus. So these neutron. So these neutron will be hitting on the nucleus of the uranium. Then it will be again some neutrons. Further also it will be the neutrons will be like this. Additional neutrons will be released. During this process, large amount of heat will be developed. So again, these neutrons will be bombarding these. Again, these neutrons will be bombarding this nucleus of the uranium. Again, large amount of heat will be developed. During this chain reaction, large amount of heat will be generated. So nuclear fission, heavy nucleus split into two smaller parts. So nuclear fission, heavy nucleus split into two smaller parts in order to become more stable. So this is about neutron. The neutron will be colliding, bombarding with the nucleus again. So it will be so again neutrons will be dividing. This again these neutrons further also will be creating another nucleus. Then due to this process, during this process, large amount of heat will be generated. So this is about a large amount of heat will be generated. So this is the reaction. This is the reaction of nucleus. So nuclear fuel is a substance that is used in the nuclear power station to produce heat, to produce heat to the power turbine. So heat is created when the nuclear fuel is undergoes a nuclear fission process. So most nuclear fuels contain heavy fissile elements that are capable of nuclear fission, such as uranium, 235, plutonium. So these are the important nuclear fuel, uranium and plutonium. These are the fuel. So this is about of nuclear fuel cycle. So now we are going to see the principal parts of the nuclear power plant. So this is about a very important component in the nuclear power plant, that is about nuclear reactor. So that is about nuclear reactor. So the main components. So we have a moderator, core. You may observe in this diagram. So reflector. These are the essential components of the nuclear reactor. So reactor core, reflector, control mechanism, moderator, coolants, measuring instruments, shielding. So like that, we have a different components, are essential parts of the nuclear reactor. So we are going to see the important components in the nuclear reactor. So you may observe this diagram. So this core. So these are the nuclear rods. So then we have a control rod and moderator. So these are the heat exchanger. Then the hot gas. So charge phase, boron control rod, graphite moderator, fuel element channel. So these are the nuclear fuel elements. These rods in the form of pellets, like as a tablet or buttons like that. So we'll be placing inserted in the pellet forms, so that uranium is in the form of pellets, like as buttons and tablets, so that the nuclear fuel complex it will be designing. So it will be placing. It will be like as a sheet one rod that nuclear pellet will be inside of that rods. So it will be called as a nuclear fuel rods. Then we have a moderator, and so these are the concrete shield, and so you may observe this. So now we'll see the various components of the various parts of this nuclear reactor. So you see in this nuclear reactor, this is about a nuclear reactor. So here we have a fuel rods. So these are the moderators, and then we have a control rods. So here, this is the hard core of the nuclear reactor. So here, nuclear fission reaction takes place. Nuclear here in this nuclear inside the. So here, nuclear reaction. So here in this nuclear, so these are the fuel rod black. It will be indicating the black that about uranium fuel rods. So it is in the form of pellets. In the form of pellets, it will be inserting constructed like this. So here we have a nuclear uranium pellets will be placing like as a one rod. So here in this nuclear reactor, so that nuclear fission reaction takes place. Due to this reaction, large amount of heat will be developed, right? So then we have a control rods. So control rods is a very important in the nuclear power plant. So the control rods will be controlling and regulating. Control rod will be regulating the fusion reaction. Control rod will be regulating the fission reaction. So it will be acting as a regulator. So it will be prohibiting or controlling. Uh, so it may large amount of heat will be developed. So much nucleus, so many neutrons will be generating. So many neutrons will be generating. So that means it will be bombarding another nucleus of the uranium. So like that, a large amount of heat will be generated. So it will be uncontrollable. So it will be uncontrollable. So it is at the time control rods will be pushing towards downside. It will be pushing towards downside. It will be pushing downside. That means it will be obstruct the heat. It will be so it will be obstructing the flow of the. That means we need to the rate of production or rate of the production of the nucleus will be minimized. Rate of the it will be minimizing the rate of production of the nucleus. It will be minimizing the uh, rate of the production of the neutrons in the particular nuclear reaction. So rate of producing of the neutrons will be minimizing by using these control rods. Rate of the production of the neutrons will be minimizing by using these control rods. So that is the important function control rod to control the rate of reaction. To control the rate of reaction in this nuclear reaction. To control, it will be acting as a regulator. Whereas in the thermal power plant, we have a steam regulating valve. So whenever we want the steam flow, so we need to regulate the steam regulating flow valve with there. So here, in order to control the reaction, we are using these control rods. In order to use, in order to control the reaction, that means we need to minimize the number of neutrons will be producing in that particular reaction. So we will be minimizing by using these control rods. So we will be pushing towards downside. So that means it will be prohibiting the generating the number of neutrons in a particular reaction. So it will be controlling the nucleus reaction by using these control rods. That is the main purpose of the control rods. So the material of the control rod is boron, cadmium. So like that, this type of material, boron, cadmium, we will be using for the material of the control rods. One more important component that is about moderator. 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 So moderator will be acting as the whereas in the control rods will be controlling the reaction. So it will be minimizing, reducing the number of neutrons produced in the nuclear reaction. So that will be the main objective of the control rod. Whereas in the moderator, it will be act as a speed breaker. It will be act as a speed breaker. That means so the neutrons so speed will be minimizing by using these moderators. Moderators. So the material of the moderator is uh, graphite. Graphite or heavy ordinary waters will be using as the moderator. Graphite materials. The speed of the nucleus that will be 15 into 10 to the power 7 meter per second. 15 into like as a speed of the light. So the 15 into 10 to the power 7 meter per second. So the nucleus neutron speed. So by using this moderator, that will be comes up to 2.2 into 10 to the power 3 meter per second. So the 15 into 10 to the power 7 meter per second will be reducing to 2.2 into 10 to the power 3 meter per second. So that will be used as the moderator. Moderator, once again, you have to remember the moderator. What is the function of the moderator? So it will be acting as the speed breaker. It will be acting as the speed breaker. In order to reduce the speed of the neutrons, we are using this moderator. In order to reduce the speed of the neutrons, we are using moderators. The main material of the moderator is graphite. As control rods, it will be controlling the reaction. Number of neutrons will be producing more. In order to minimizing the rate of production, we are using control rod. Whereas moderator will be reducing the speed of the neutrons. Both are important in the nuclear reactor. So here large amount of heat will be developed. Large amount of heat will be developed. So if the control rods is not there, so it will be forming as like a nuclear bomb. It will be forming as a nuclear bomb. So high radio effect will be there. High radiation, radioactivity of neutrons will be there. So that we are using control shielding also. Control shielding also. If the control rods are not using properly, it will be forming as a bomb. So due to large amount of heat will be generated, due to large amount of heat will be generating in the, so we if not controlling, so it will be forming as a nuclear bomb. So that is the main disadvantage of the nuclear power plant. Then we have a control shielding. Control shielding. So if the radiation is very high, so we are using the control shielding, and also we are using coolants. Then this heat will be carried away with the heat, and then the heat will be going to the heat exchanger. These are the important components of the nuclear power plant. Nuclear reactor core. In this nuclear reactor core, the nuclear fission reaction takes place. Then control mechanism. The control mechanism will be control rods will be using for that. So cadmium, the material of the control rods is the cadmium. That zirconium control rods will be, if the control rods will be not using properly, so it will be forming as a nuclear bomb. Right? Then moderator will be acting as a speed breaker. I already told the moderator will be acting as a speed breaker. Then coolants. We need to cool a large amount of heat will be generated. So we are using the coolants. And then radiation shielding in order to protect the radiation. So we need to use shielding. These are the important parts. So we have seen the control rod. Control rod limits the number of fuel atoms that can split. So I already told, it will be minimizing the neutrons produced in the nuclear reaction. Control rod limits the number of fuel atoms. It will be limiting the number of fuel atoms. It will be limiting the number of fuel atoms that can split. They are made of boron and cadmium. Which are absorbing the neutrons. So these material, the control rod materials will be made by cadmium and boron, so it will be absorbing the neutrons. Then we are using coolants. They carry the intensity heat generated. So what is used as a coolant? Some reactors use as a sodium as a coolant. So it will be absorbing the heat. So what is used as a coolant? Then uranium fuel. The fuel used for nuclear fission is uranium 235. So then we are using radiation shield. So thermal shielding. It will be protecting the people from working from the radiation fragments. So the radiation shield will be using in the nuclear reaction. It will be protecting the people working from here. So from the radiation and radiation fragments, we are using radiation shield. So these are the important components of the nuclear reactor, the main parts of the nuclear reactor. So the chain reaction is not shown down. So the rate of fission increases rapidly. I already told the chain reaction is not slowed down. So the rate of fission increases rapidly. So a huge amount of energy is released very quickly. So it will be converting as a nuclear bomb. So that we need to use control rods. Boron, cadmium, we will be using for the control rod. The materials of the cadmium, the materials of the control rod is a boron and cadmium. So if the control rods we are not using properly, so large amount of the rate of fission increase rapidly. So huge amount of heat will be released, so that it will be forming as a nuclear bomb. So these are the important power plants, nuclear power plants. So the pressurized water reactor and boiling water reactor. So here. So we observe in the diagram. So here the large amount of heat will be generated in this nuclear reactor. That heat will be going through this by fluid pipes. So then we have a heat exchanger or a steam generator. So here the water will be flowing like this. So here the water will be absorbing this heat and it will be converted as a steam. Then the steam will be striking on the turbine. Steam will be like as a similar thermal power plant. The steam will be expanding in the steam turbine. So that means the mechanical energy will be generated here. So here the heat will be generating here. We're using that heat to convert the water into steam in the steam heat exchanger or steam generator. So here the water will be going to the steam heat exchanger. So heat will be carried. So heat will be given to this water and water will be absorbing the heat and the water will be converted as a steam. So that steam will goes to the steam turbine. That means steam will get expanded and it will be, the mechanical energy will be generated. The steam gets expanded. That means rotor of the turbine shaft will be rotating. That means generator of the mechanical energy. So further it will be converted that the output of the mechanical energy will be given to the input of the generator. Further it will be converted as a electrical. So these generator shaft will be coupled with the turbine shaft. Again, after striking of the turbine, after the steam will be get condensed. The steam will be get condensed and the cyclic process here. The same manner of the cooling tower we are using in the steam power plant, like that we are using change process condenser. So again, that condenser phase changing process, we need to use the cool saturating water will be sending into the heat exchanger. So this is about cyclic process. So this is about working of the nuclear reactor in the nuclear power plant. In this way, so power will be generated in the nuclear power plant. I hope you are understanding the concept of the nuclear reaction in the nuclear reactor of the nuclear power plant.